Let's now develop further the birthday class by adding a new command. So let's go under the feature section for commands over here, and then let's add a new command. Of course, we just choose a conventional name for command that will be used as a constructor. So notice one thing here. For Eiffel, unlike Java, for Java you have no freedom as to the name of the constructor for the class. It has to be the same name as the class name. However, in Eiffel, it does give you the flexibility to make any name you like as the constructor. However, there will be some extra step you have to take syntactically, which I'll show you. But let's now just define the normal command. Let me just call that make. So typically, if you have like a substring make in your command name, that more or less suggests that command may be used later as a constructor, but does not have to be, but just conventionally. Okay, let's say make. How do we actually make some changes to the birthday? Since we got two attributes for month and day, so why don't we take two parameters for the make? Okay, so make is going to take two parameters. Remember, they are going to be separated by semicolon. So I would say, and you cannot give the same name. Okay, so shadowing for variable is not the case for Eiffel language. So you're going to say, for example, I can say n of type integer, semicolon, and d for day of type integer. Okay, let's not worry about pre and post condition just yet. For now, let me go straight to the implementation. So I would simply say do and end. And don't forget, in the absence of require, it's as if you said require true. In the absence of ensure, it's as if you said ensure true. But usually speaking, if you simply leave out the precondition and postcondition for a particular routine, it's not a very good sign because you should really make use of contracts. But for now, just for illustration purpose, let's go directly to implementation. So now how do I assign? Very similar to what you normally do in Java. But now in this case, we don't really have to use the this. Well, it's not called this in Eiffel, it's called current. We don't really have to say current.month is assigned to m. We don't have to because the names themselves would create no confusion. So I can simply say month is assigned to m, and also day is assigned to d. Okay, I'll simply just do this variable assign, very similar to what you did before. And again, call it equal is for variable assignments, equal sign is for comparison only. So we are done with the implementation for this command, make. At the moment, make is not really a constructor. It can only be used as a command. In order to make it a constructor, we have to do the following extra step syntactically. Okay, let me do it, and then I will explain to you what if we didn't at the end. Okay. So now let's go to, so it has to follow this particular order. So right after the class, before you mention any feature, before the beginning of the first bookmark, feature bookmark. So here I gotta say create over here. Create is a keyword. And then it's going to, under the create is going to be a list of names of commands. A list of commands that can be used as constructor. So as soon as you declare the name of some command under the creates, that command can actually be used also as a constructor. So you have to take that extra step. If you didn't do it, then your command cannot be used as a constructor. Okay, let's list it. Just list the name. You don't have to redefine the command. Okay, I can say make over here. Okay, so that's done. Let's make sure everything compile. And remember test-driven developments. Now that we have completed the implementation for command and also command make, and also we declare that as one of the possible constructors for birthday class, we can now write a simple test case for that. So, okay, remember test-driven development. Always write a test as early as you can. So if there's any problem, we can find it earlier. Always remember to practice this. Let's now switch the context to the test class. Let me first of all open a new tab over here, and then under the cluster tests, and then I'm going to test birthday. Okay, that's a class we created before. And let me maximize it. And we want to add a new Boolean test query, which we did previously. Okay, I'm just gonna continue from here. Let's now let's give an informative name. So let's say t, let's say creates new birthday. Okay, it's going to be a valid birthday. That's going to satisfy the invariant. But we want to see also how to use the syntax for creating a new object, which is also important. Because now we are not calling static queries anymore. in which case you could simply just use a class name to actually call the static queries. But for now, we have to create this particular object, so we have to declare that. So let's declare a local variable for this particular Boolean query. So we'll declare local here, which is part of the implementation. Let's call the local variable BD. And then BD is going to be an address that is a member of all the possible addresses for birthday objects. Okay, birthday here. And then in the implementation here, we're going to try to manipulate this BD by by storing some address into it, the birthday objects. Conceptually, creating a new object in Eiffel is just like creating a new object in Java. It's just that the syntax is a little bit different. So let me explain that before we come back to the code. Okay, let me switch to my iPad here. So I already listed over here how you would do object creation in Java. Okay, so let me just review some terminology with you, which will be beneficial for later as well. Let's say over here, so we definitely have to use the the new keyword over here for creating a new object. In the case of Eiffel, we have to use the create keyword. Think about the create keyword in Eiffel is like the new keyword in Java. And then over here, we declare the type over here for BD. And also we say dynamically what should be the type for the object that we're going to create, right? So we have some special term for this. And the birthday over here is called a static type. Whereas the birthday over here after the new keyword is the dynamic type. And we know very well from the previous OOP course that static and dynamic types, sometimes they might be the same, but in general they may be different. More precisely, dynamic type over here should be a descending class of the static type with respect to some inheritance hierarchy. That's kind of a part of the inheritance subject, which we'll review later in the course. But for now, I just mentioned that quickly. Okay, and then you will pass an input value over here, right? That's how you would do. These are all the ingredients for creating a new object. And of course, you have some variable assignments, which means that the address of this particular new object is going to be stored into this variable here, right? So now, how do we do it? It's actually not hard. Okay, so let me try to first of all show you one version that's actually very similar to what you're seeing over here. Okay, so now what you would do is first of all, you're going to declare the variable like what we did before. Okay, so you're going to say BD, first of all, is going to be birthday. This is something we did already. So usually when you declare variables, it could be either a local variable or it could be attributes, right? Depends. And then now for this particular assignments, what will be the corresponding Eiffel code? You would say, let's say here, BD over here is assigned to, okay, so colon equal for assignments. And then I'm going to say creates, which is a keyword, okay? And then this is the dynamic type, right? And then what I'm going to do is to really specify the dynamic type, you have to enclose it within a pair of curly brackets. So you would say creates birthday. And now in Eiffel, because in general constructor can be of any name, unlike in Java, it's always the same as a class name. So here we have to disambiguate. But so here we're going to say dot. Okay, so it's like a class calling the constructor. And then in our case, it's going to be the make command, right? It's being listed under the create clause to be a possible constructor. And the make and 10, 15. So this is very close to the Java version, like how you would do it in Eiffel. Okay, let me just say one more thing over here. It's really important to notice that here, this particular guy here alone is an object expression. Okay, it's called anonymous objects. It's like an object without any name, but it has an address. Okay, let me write it down. So this alone is an object expression. Which corresponds to what you have over here. That's also an object expression over here, right? That's also, okay, let me draw a little bit better. That's also an object expression over here. They're really corresponding to each other, okay? And then it's called anonymous objects, and which will be very handy later on when we try to create different objects. So let me write it down. So this is called anonymous objects. Okay, so now this would be fine. However, there is a simpler syntax for doing this. Okay, let me show it to you. Okay, rather than having an assignment over here to do the object creation, well, this is definitely fine. I did it just because I wanted to make it like Java code. However, the Eiffel way of doing this would be like this. Okay, so you can say creates, start with the creates rather than an assignments. So creates, and which object do you want to create? I want to create a birthday object, right? Like the birthday here. So again, curly brackets over here, birthday. But now I need to disambiguate by saying which variable do I want to store the address of the created objects. So now in this case, I would say it's the BD over here. So I would say BD dot make 10 and then 15. This also works. Okay, you can think about, I got different alternative for you, either solution number 1 or solution number 2. Okay, both work. Solution number 1 just looks a little bit more similar to Java. However, once you get used to it, I think solution number 2 is actually much neater. Okay, however, to make the situation even simpler for you, okay, in the special case where the static type, so this is the static type, and this is the dynamic type, right? As we said before, this is the dynamic type. When the static type and dynamic type are actually the same, right? You can see these two are actually the same. In this case, you can actually omit this particular part. And then Eiffel compiler would know if you actually omit this particular part, then dynamic type will just be the same as a static type. So overall, this is what we can do. Okay, let me come back here. And then version number 3 would be, I can say creates, and then rather than using curly brackets, I don't need to because dynamic type will just be the same. Creates BD dot make, and then October 15. Okay, so now we got 3 different versions of the Eiffel creation that you can use. Case number 3 is only possible if the static and dynamic types are the same. If they are not the same, you can only use either 1 or 2. Okay, it's kind of completely up to you. Okay, just make sure you understand the illustration over here, and then we can go back to Eiffel Studio to complete the object creation. In this case, let me just do option number 3 because it's the simplest one. And then later on, we'll see how you can use anonymous objects. Just get used to it, right? It's very, the idea is really the same. Conceptually, there's nothing new. It's just the syntax you have to learn. Okay, so I'll simply say creates BD dot make, and then over here I can say, for example, October 15th, right? So now how can I write a test case for that? Well, I can simply say result is assigned to let's say BD dot month should be equal to 10, and also BD dot day is equal to 15, right? So now all is good. Let's make sure we compile. Before we extend this particular test query over here, let me just add it. Well, make sure it's actually added to the test case, right? Remember, you have to do this. So I gotta say add Boolean case agent T create new birthday, right? Okay, so now let's compile and run the workbench system. Make sure everything's okay. And so I'm gonna say run over here and then run workbench system. Okay, everything is good. Oh, I forgot to put some comments over here, which is not good, right? Let's go back to the code and let's go back to that particular Boolean test query. And please don't forget, you always have to put the comments over here for your test case. Otherwise, the test report wouldn't make sense. Okay, so now let's say we're gonna put a string crow over here. First of all, let's get the name of the test query, colon, and then you can say create a valid instance of birthday. Okay, everything's good. So now I want to do another thing. Okay, I want to show you 2 things over here, right? Remember what I said before. In this case, because make is actually under this particular creates. So that means make can be used for two purposes, either as a command or as a constructor. So that's something I would like to show you. And then I can also show you a little bit about how to use breakpoints in Debugger to really convince you. Okay. So what I would like to do now is go back here. And then, of course, if I want to have more than one reassignments to result, I need to have intermediate check assertion. We did that already, right, in the previous video. So check result n. What I want to do now is I want to say creates bd.make, let's say maybe September 14th, let's say. Okay, and then what I would do is I would say result is assigned to, okay, let me just copy that, and then one more, okay? Of course, that would be September 14th. Result and, okay, just one more. And now you can see, how about this? Let me just make a comment right away, okay? Command make is used as a constructor. Similarly, over here, command make is used as a constructor. Now, I want to see if I can use make as just a command rather than as a constructor. So I'm going to say just bd the make over here. And then let me say maybe July 15th, let's say. Okay, and then I'm gonna just copy this one here. It's getting a little bit tedious, but I think it's worth doing because I do want to show you a very important point about using make either as a command or as a constructor. It's very important because normally students also have this confusion. So now let's say 7 over here, and then we have 15th here. Okay, before I try to explain this one here, let's now try to run the workbench system. Okay, everything works. Okay, let me go back to the code. So let me use my iPad to help me state a question to you. Okay, let me switch. And this is the same block of code for the test. Okay, I would like to highlight 3 lines for your attention before I state my question. The first line, let me use blue over here. So it is this line over here about using the make as a constructor. And the second line, let me use green. That one there, just another use of BD as a, using make as a constructor. And then finally, the third line, we're using make as a normal command. Okay, these 3 lines. So here's my question. After executing these 3 lines, how many birthday objects have we created? Okay. You might think it's a very easy question here, but believe me, many of your previous fellow students actually have had confusion about this. That's why I would like to clarify in the beginning. Okay? So the answer should be, let me write it down over here. The answer should be 3. 2. I got myself confused, sorry. So it should be only 2 birthday objects that will be created. Okay, of course, BD eventually only points to 1 object at a time, right? So let's see why this is the case, right? Or why 2 objects will have been created. So first of all, let's see the first line, the blue line. By using make as a constructor, because we're using the create keyword here. So what's going to happen is, first of all, we're going to create a birthday object over here. And every birthday object has the month and the day. And it's going to be 10 and 15 in this case. And then BD is going to store the address of this new object, right? So BD is pointing to this particular object. So hopefully you are fine with this visualization. So throughout the course, since we are talking about design using OO, so there will be many times that we have to use visualization to explain concepts. So hopefully you are fine. Otherwise, get in touch with me. Okay. So what about the second line? So the second line over here, the green one. So we are using the create keyword the second time. So that means a second birthday objects will be created separately, right? So that's also birthday. So it's month and also day. So in this case, it will be September 14th. September 14th. And then we are also storing the address into the same variable. So it's as if we are trying to redirect the pointer over here. So BD, rather than pointing to the blue, is now going to point to the new green objects over here. Okay, hopefully okay. We also call that, well, when you actually study OOP, something called aliasing is actually result from reassigning the pointers, the variables. Okay, the third one over here. So now there's no create keyword over here. That means no new object will be created. So what we'll do is we're just going to modify whatever BD is pointing to. So be more precise. BD is actually pointing to this particular object over here, and we're modifying just that object. So what should we modify that into? So 7 and 15. So 7 here and then 15 over here. So that's why eventually there would have been only 2 birthday objects that we have created. Okay, so hopefully you're okay with this distinction here. So the message really is, for any command in Eiffel, you can definitely use that as a command for sure. Or you can also alternatively declare the command under the create clause. So it can also be used as a constructor. So that's exactly what happens to make over here. So you have to be aware of the distinction between the 2 different usages. Okay. So now what I would like to do is I would like to show you in the code over here. What if let me go back to the birthday clause over here. Okay. And remember, this is an extra step I said you should do. You should explicitly declare that command that can be usable as a constructor. What if I comment it out? So I would say Control K over here and then save. Okay. If I hit the compile to really have this new change to take effects, is everything going to compile? Specifically, let me go back here. The 3 lines I just explained to you. Line number 1. Line number 2 and line number 3. Are these 3 lines specifically still going to compile? Okay, think about the answer. Okay, think about the answer. And then let me try that. Okay, if I go back here and then I will hit recompile, and now we actually got 2 errors over here. Let's see what errors are they. Okay. As I said before, whenever you got compilation errors, don't be too terrified. There are certain tools you can actually use to really debug. So first of all, you can double click. If I simply double click on the first one, it's telling me the use of make over here is actually invalid. So the first error is exactly the blue one over here. So this one is actually having some trouble, right? I'll just put a cross mark over here after I've taken out the make from the create list. What about the second one? The second one over here is actually the second use of the create for the make as a constructor. So the second one here is the green one that's also invalid. But why? So hopefully you can see the reason is quite obvious. In these 2 cases, you're actually using the make in the context of some creates. However, make was not declared under the create because I took it out already, right? That's why we actually got error over here. So now you can also try to read the error message a little bit. I'll just show you quickly. Okay, so the error message sometimes may not be so much comprehensible, but you might be able to get some little bit hints about what's going on over here. Okay, let me just read the first part here. They said error creation instruction uses call to improper feature. Okay, maybe the make feature, the make command. What to do? They're suggesting some resolution. Make sure that the feature of call, which is make, is a creation procedure. Aha! How can we make the make a creation procedure? Well, as I said before, you gotta take that extra step by making the make under creates. That's what you gotta do. Okay? Hopefully that makes sense to you. Okay? And then let me put it back, and then I'll simply just compile over here. Okay?